Hi, in this second video, I will give you the next example of the heat conduction in one dimensional. Let's begin with the problem. So what is the thickness required of a masonry wall having thermal conductivity of 0.75 watt per meter Kelvin if the heat rate is to be 80% of the heat rate through a composite structural wall having a thermal conductivity of 0.25 watt per meter Kelvin and a thickness of 100 millimeter. Both walls are subjected to the same surface temperature difference. So the solution, first we know that the masonry wall of non-thermal conductivity has a heat rate which is 80% of that through a composite wall of prescribed thermal conductivity and thickness. So we need to find the thickness of the masonry wall. With the assumption, first, both walls subjected to the same surface temperature, one-dimensional conduction, steady-state conditions, and constant properties. So here is the schematic. So first we need to draw the schematic of the masonry wall. For example, this is the wall. Okay. So we need to find here the L1. Because the L1 we need to find. And here we have the heat loss or heat rate Q1, and we have the heat conductivity here equal to 0.75 watt per meter Kelvin. And next, for the composite wall, this is composite wall. So for example, this is the wall, okay, and we have this is the thickness of L2 equal to 100 millimeter, and this is the Q2 with the K2 is equal 0.25 watt per meter Kelvin. Okay, remember we need to find the L1. So for the steady state condition, the conduction heat flux through a one-dimensional walls is follow the Fourier's law. We already know that the Fourier's law, the Q double prime equal to K delta T over L, where the delta T represent the difference in surface temperature. And since the delta T, okay, the delta T is the same for both walls, it follows that the L1 equal to L2 multiplied by K1 over the K2 multiplied by Q2 double prime over Q1 double prime. And we know that the relation between the heat flux here is 0.8 of the Q2 double prime, or 80%. Therefore, we will have the L1 will be equal to 100 millimeter multiplied by 0.75 over 0.25 multiplied by 1 over 0.8. So we will have the thickness of the masonry wall is 375 millimeter. So that is the solution. Thank you for watching.